Software is everywhere. It's in our phones, our cars, and even our refrigerators. When software fails, it can be more than just an inconvenience. It can have serious consequences. That's why software testing is so important. Testing helps ensure that software is reliable, functional, and safe. Think of building a house. You wouldn't wait until the house is finished to check if the walls are straight or the plumbing works. You would inspect the plans, check the materials, and test each component along the way. Software development is similar. Testing throughout the development process helps catch errors early, saving time and money in the long run. Just like a house needs a solid foundation, software needs rigorous testing. Static testing is one such testing method that examines the software's blueprint before execution. It's like inspecting the architectural plans before a single brick is laid. Static testing analyzes software artifacts like code and design documents without executing the code. Imagine reviewing blueprints for a bridge before construction. You're looking for flaws, potential weaknesses, or missing elements. That's what static testing does for software. It's a proactive approach to identify defects early in development. Static testing acts as a safety net, catching issues before they become major problems. Static testing involves several techniques, each with its own strengths and areas of focus. One common technique is review. This involves carefully examining documents like requirements, specifications, and design documents. Reviewers look for inconsistencies, ambiguities, and missing information. Another technique is inspection. Inspections are more formal than reviews. A team of experts systematically examines the software artifacts, following a well-defined process. They use checklists and guidelines to identify potential defects. Finally, walkthroughs involve the author of the artifact walking the team through their work. This helps to uncover any hidden assumptions or misunderstandings. These techniques are like using different lenses to examine a specimen under a microscope. Each lens provides a unique perspective, allowing us to detect flaws that might be invisible to the naked eye. Imagine a team developing a mobile banking app. During static testing, they might review the requirements document to ensure it clearly defines all the features, security protocols, and user interface elements. They might also inspect the code for potential vulnerabilities, such as SQL injection flaws or cross-site scripting vulnerabilities. In another scenario, consider a team building a traffic management system. Static testing would involve analyzing the design specifications to ensure the system can handle peak traffic loads and prevent gridlocks. They would also scrutinize the code for potential logic errors that could lead to incorrect traffic light signaling. These are just two examples of how static testing is used in the real world. From financial applications to healthcare software, static testing plays a vital role in ensuring the reliability and security of the software we use every day. Section 5. The benefits of static testing: saving time and money. Static testing offers numerous benefits, making it indispensable. Early defect detection is a key advantage. It prevents defects from becoming costly later. This reduces development costs significantly. Fixing defects early is less expensive. Static testing also improves code quality. It enhances maintainability and security. It fosters better communication and collaboration. Section 6. Static versus dynamic testing. Two sides of the same coin. Static testing and dynamic testing are two fundamental categories of software testing. While static testing examines the software without executing it, dynamic testing involves running the software and observing its behavior. Both approaches are essential for delivering high-quality software. Think of it this way. Static testing is like checking the ingredients and recipe before baking a cake, while dynamic testing is like tasting the cake to see if it meets your expectations. Static testing ensures the foundation is solid, while dynamic testing validates the final product. Static testing excels at finding defects related to design flaws, coding standard violations, and security vulnerabilities. Dynamic testing is better suited for uncovering runtime errors, performance bottlenecks, and usability issues. By combining both approaches, we get a comprehensive view of the software's quality. Section 7. Common misconceptions about static testing. Despite its benefits, static testing is sometimes misunderstood or undervalued. One common misconception is that it's time-consuming and slows down the development process. However, the time invested in static testing pales in comparison to the time and effort required to fix defects later in the lifecycle. Another misconception is that static testing is only about finding coding errors. While it's effective at uncovering coding defects, static testing also plays a crucial role in ensuring the software meets requirements, adheres to design principles, and aligns with user expectations. Some believe that static testing is only necessary for large, complex projects. However, even small projects can benefit from static testing. A simple code review can uncover potential issues that might otherwise go unnoticed. Section 8. Integrating static testing into your workflow. Integrating static testing into your development workflow doesn't have to be complicated. Start by establishing clear coding standards and guidelines. This provides a common framework for developers and reviewers to follow. Next, introduce regular code reviews as part of your development process. Make use of static analysis tools. These tools can automatically scan your code for potential issues, such as coding standard violations, security vulnerabilities, and code complexity. Finally, foster a culture of quality within your team. Encourage developers to take ownership of their code and to view static testing as a valuable part of the development process. Remember, static testing is not a one-time event. It should be an integral part of your development lifecycle, from requirements gathering to deployment. Section 9. Tools and resources for effective static testing. A wide range of tools and resources are available to support static testing activities. Static analysis tools automate the process of analyzing code for potential issues. These tools can identify coding standard violations, security vulnerabilities, and other code-level defects. Review tools facilitate the process of reviewing documents and code. These tools provide features for tracking comments, managing defects, and generating reports. Training and certification programs are available for those who want to deepen their knowledge and skills in static testing techniques. The internet is also a valuable resource for finding information, best practices, and case studies related to static testing. By leveraging these tools and resources, you can enhance the effectiveness of your static testing efforts and improve the overall quality of your software. Section 10 Conclusion. Embracing static testing for superior software. In the ever-evolving world of software development, quality is paramount. Static testing, with its proactive approach to defect detection, plays a crucial role in building robust, reliable, and secure software. By embracing static testing as an integral part of the software development lifecycle, we can deliver superior software that meets the needs of our users. Remember, static testing is not just about finding bugs. It's about building better software from the ground up. By investing in static testing, we invest in the quality, reliability, and security of our products, ultimately leading to greater customer satisfaction and business success.